So let's take a look at what an impulse response looks like in an image. So here we have an impulse, okay, and so here's our impulse, right? It's just a single pixel with a value of 1, okay? And we're going to filter it with some kernel h, okay? Remember, kernel, mask, thing that we're moving around in order to make or our filter. So we have our h. So the question is, what is the output? And again, I want to thank Kristen Grauman for having made these slides so I can change them, steal them, move them around. So first I put down my filter, and you see my filter is over here like this, right? So it doesn't hit that 1 at all, and so its value is just going to be a 0. Fine, no big deal. All right, now move the filter over a little bit. Well, it just pulls out the f here, right? So this pixel right there pulls out the f, so an f goes right there in my result. Move it over one more time, what do I get? I get the e. Move it over one more time again, what do I get? I get the d. So you notice that even though the filter goes d, e, f, left to right, in the image what comes out is FED going the other way, and that's just because of how this correlation pulled it off. And it won't surprise you that not only does it flip it left and right, it also flips it up and down. And that's what happens when you do a correlational filter of a impulse. Just because of the way you slide it over, you'll end up flipping that entire response. By the way, something that I was being implicit about is I was assuming that the center of that filter was what we were calling the reference point, right? So wherever the center was located, wherever that center pixel, that was the one that was being entered into on the result, okay? You could use a different point, but we're going to just assume that the center pixel is the reference pixel of the filter.